All right, so in this video, I built a Streamlit app that lets us talk to our CSV files, basically tabular data. So I already have a file that I've uploaded, and I provided this question. What's cool is we not only get a response, a text response from the model, but I have found a way, or I'm using a little trickery to also provide a chart that goes along with the answer. All right. Hey, I'm going to walk you through exactly how this happens and how I did this, okay? And before I get going, if you find the rest of the video helpful, useful, and/or interesting, please do consider subscribing to my channel and liking this video. Also, everything that I'm going to show you and cover in this video is provided in a link in the description, okay, including the code, which I will unpack in a little bit, in a few more minutes. I'll unpack the code for you because it's important that I show you, what's what in the code in case you plan to use it. And lastly, I have in the past done a video showcasing how to use Pandas AI to basically do what I just did here. And I wanted to do this because it doesn't require any other APIs like Pandas AI, and you can pretty much do this without having to rely on Pandas AI. All right. Okay. So now, this is pretty cool. Gives you the answer and gives you a chart that goes with the answer. All right. But I want to show you basically what's happening here. So the app asks for the path to your CSV file, and basically we upload that CSV file to Sqlite3. All right, and there's a link in the description that takes you to the website from which you can download if you don't already have Sqlite on your local machine. All right, it's free. So that's the first thing. We load the file to the database, okay? And then the second thing here I want to tell you that I'm doing with this app, or I've done, is basically I have two functions I created. There's a couple of other functions in the code, but two functions that we eventually pass off to along with the prompt to the model. So the first function that gets passed along with the model is the one where we take the prompt that's in natural language, the question, and we generate a SQL query based on the user's prompt. The second function is basically going to take that query and run that against the CSV file that we uploaded, right? Which will give us a numerical output. And so I'll show you that just exactly, how that's done, and I'll even unpack a little bit what Google function calling with Gemini API is all about. And then lastly, here's the structure of the app, the code itself. We get the user's question or the prompt, we pass the prompt along with the two tools or functions that I talked about here to the large language model, in this case Gemini 2.0. And then the large language model, the model's first going to, because it's got two tools now, it's going to recognize that, hey, I got to convert this question into a query. It's going to do that, and then it's going to pass it to the second function, second tool that we provided, and then runs the query against that data. And then two things happen. One is in this initial function where we get the query, I also am asking the language model to say, hey, recommend a chart type that would go along with the data. All right, with the answer basically. So two things happen. One, we show the chart that I just, this guy here, and we also provide the answer back to the user. So here's the answer and here's the chart. So that's basically the breakdown in a very, very high level of function calling with Gemini API. Basically lets you connect, in this case Gemini 2.0, to external tools and APIs. And so, this is in my GitHub repo. You can read for yourself, but that's what we're doing, okay? And Now let's do a couple of questions here, okay? Let's say, what are the average loan amount by gender? And I am basically printing out the tokens that it's using up. That's in the code. If you don't want to do that, you can, comment that out. And what I wanted to show you here was, okay, so create the answer, and you get the chart that goes along with this. And I'll show you very shortly the code itself and how it's doing all of this, okay? And so I'm going to say, how about by loan status? Okay, it's basically in this app, what I'm doing is I'm passing the history to the models. So this way I didn't have to say, hey, what are the average loan amounts by loan status? And I'm just following up my other question and say, how about by loan status, right? So that's part of what I've done with the code, is so that you could do some follow-up questions. All right, now I've shown you the app. The code is provided, so you can build the same app, and you can go at it. Let me unpack the code itself. So we start with basically, the way I do things. You're going to need a Google API key. If you're not, you need to go get one. And then we just basically create a client with the API key. In this case, we're using 2.0 Flash. And then you do have to initiate this, a connection. Basically, just it's in memory. Okay, so when you're done with the app, or you close the app out, it's also going to close it out. And here's basically, it starts with providing the file. It reads the file, and in this, I'm going to walk you through the schema. The most important part here is the schematic that we provide to the model, and it's basically providing the metadata associated with your file and field descriptions. I'll walk you through that shortly, but basically, we read that file location, we read the CSV file, and in my schema, there's already a table name, and I'll show you all of that stuff. And basically, we pass the data frame to Sqlite3. We create a table in that database, etc. And here's I'm providing some system instructions, which is always a good idea. But here's a dictionary that we're going to pass along with we're going to pass this to the model. And basically, what we're providing here is the two functions that's as tools for the model to use, setting the temperature and passing the instruction, system instruction. And basically, we create a chat and take the user's input, and we send the prompt and this tools to the model. And then in this case, this is the first thing it's going to do, because you were basically telling the model that this tool, get query tool, is meant for retrieving SQL query based on user prompt, right? So it will that's the work that Google does on our part. The API does, Gemini API does on our part. So basically, it takes a prompt is fed here, and here's a big old system message that I created. Lots and lots of trial and error for text to SQL. Text to SQL is pretty tough. I mean, your prompting has to be good, and you got to provide a very, very detailed sort of a prompt or a message to the model. And so with a lot of trial and error and a bunch of help from the internet, here's what I've done. It's a pretty lengthy message, but what I learned was that it's good to provide a bunch of examples. So if a user asks, hey, list all loans with a principal amount greater than 10,000, then hey, here's the simple query, and hey, you should recommend a chart. In this case, none, but in this case, recommend a pie chart. So you have to do all of that work in here, right? So you got to provide not just the example of what the query looks like, but what the recommended chart should be. All right, let me take you to the schema here. Now we'll come back to the functions here. So this is the schema that this JSON-like string I provided. Okay, so here's the table name, and here's the first field, and it's a string, and I provide it. So this is easy for us to, like, have a code that will just go get that, the field name and the data type. Okay, but this I had to type it in, and I'm going to walk you through a code that I'm going to give you as well that can create the schema for you. Okay, based on your CSV file. But here's the schema that I provided in the code at the very beginning here. So coming back to the get query function, here's the schema that we're passing along, and I'm passing it along a couple of times in here. Okay, so pretty straightforward. And the second second function, or the tool that's provided to the model, is, it says, hey, use this to execute the SQL query against, well, this in this case is not BigQuery, because in my original code that I'd written, or basically for myself, that when I built this app, my table was in BigQuery, but in this case it's SQLite. Okay, and here it basically takes the query, runs it, and returns the data. Okay, and this is the trickery that I do later, where I take the data and I parse it out, and that's provided to basically this function here that gets the chart. And this is the part that I had to play around with, but I figured out how to do all of this stuff. It's yours if you want to use it. So what I've done is I limited to 3 different chart types. I mean, if you want to do others, you're going to have to figure that out for yourself. But I focused on the 3 primary ones: bar chart, line charts, and pie chart. Okay, and so the model that we sent that prompt and the tools to the model, we write down the response. That's the text response, and then here's the function we call. Basically, first I call this function parse data, so we can figure out what the chart type is being recommended, and the actual data that we get by running the query. Those 2 things are sent to this function, which is basically plotting the chart. All right, and quickly, this other code, if you want to use it, let's say you got a table here, a CSV file, you read that into a data frame, and then we create the schema by calling this function here, create a schema string, and here's some description in terms of what the arguments are and what's being returned. Okay, the key here is basically this is a straightforward way to read column names and data type from any data frame, right? So that's all it's doing. It's going column by column, and appending that to the schema. But the key here is, and this is where you have to type in the description. Okay, you would have to provide the description basically, and I'll let you figure out how to do that. Okay, or you can just take my schema that I have here, and you can replace that with your schema based on your tables, your files, metadata. Okay, there you go. That's what it takes. But code is yours. I'm sure you're going to have to modify things so that it works to your use case, for your use case. But this is key. Schema, providing a description, really helps. You don't have to. You can just take this out. If your column names are pretty straightforward, for the most part, they're going to be. These models are pretty good. Like they will do an adequate job, right? But I think it helps to provide the description. And but in this case, you're going to have to provide the description, okay? Because it's going to read this part, and and it's going to create a blank description. You're going to have to go type it in. Back to the app. Pretty cool, huh? Some trickery and some just trial and error. I figured I'd do a video and share it with you. If you find this, helpful for your use case, go at it. You're getting the code. I hope it works out. If something doesn't work, nothing in here is rocket science. You can just go Google it, and you'll find the answer. Hope you found this helpful, useful, and/or interesting. And if so, please consider subscribing to my channel. Until next time.